Welcome to this new unit, 1.2.4, looking at data storage and numbers. We're going to be explaining how binary is used by a computer and understand basic binary numbers. So by the end of this lesson, you should be able to explain what is binary and how is it used on a computer. Now, can you solve this puzzle? You probably won't be able to solve it yet, but hopefully by the end of the lesson, you'll be able to figure it out. There are 10 types of people in this world: those who understand binary and those who don't. Pause for a second and think, can you solve my puzzle? Here's our keyword wall. You should know all of these keywords by the end of the unit. Have a look at this keyword. Can you find the word which would be half a byte? That would be a nibble. So a nibble is 4 bits, remember, which is half a byte. Can you find the word which is 1000 bytes? And that would be a kilobyte. Which word on here is its abbreviation TB? That would be a terabyte. Now remember back to our last unit. We know that a computer can only store data in zeros and ones. Think of this like a switch. It can only have 2 states, an on or an off. We represent that by a 1 and a 0. We know computers are built using electricity and that they can only have those 2 states, so either 1 or 0. Remember, it's not just binary that's a 1 or a 0. Everything that we did, including storage for optical, for magnetic, and for SSD, stores data in 2 states. To start with, you've got 2 pages in your workbook. Please find your new workbook and complete the 2 recall pages. Pause the video and do that now. Now, when we're counting, we actually only use 10 different numbers. The numbers 0 to 9. Notice how it starts at 0. We can make any number from these 10 different numbers. The number 56, we just use 5 and 6. Binary, as we know, can only be on or off, so it has 2 options. We call this base 2 because there's 2 options. Denary, sometimes known as decimal, is called base 10 because we have 10 different options. So binary is base 2 and denary, sometimes called decimal, is base 10. Now, to try and explain how we can learn binary and binary numbers, I'm going to show you a quick strategy. On your right hand, I want you to draw these numbers. This might be quite hard because you're going to have to use your left hand to write and try and write them out. Now, if we have a number such as 1, close your hand so it makes a fist and put your thumb up. You'd see you can only see the number 1. So reading from the left hand side of our hand, that would give me the number 0, 0, 0, 0, 1. When we have a finger down into our palm of our hand, that is a 0. When we have our finger pointing upwards, that is a 1. If we were to make a 2, all your fingers would be down except for your pointing finger, so you can see the number 2. So we look at our hand straight on so we can see the palm of our hand. Our first 3 fingers should be down with our pointing finger up and our thumb down, and that would give us the code 0, 0, 0, 1, 0, because this finger would be in here, this one's down, 2 is up and 1 is down. Now that's great until we get a number which isn't included on our hand, such as the number 3. Well, the only way we can make the number 3 is by adding 2 digits together, so a 2 and a 1. So if you're looking at the hand the same way as it is on the screen, I'd put 16, 8 and 4 down and keep 2 and 1 up. This would read 0, 0, 0, 1, 1. I want you to watch the following video to give you a little bit of a recap about what binary is. In your workbooks, try and answer the first question. Why do we use binary? Please pause the video and complete this task now. You should hopefully have figured out that we use binary or binary digits because a computer can only represent a 1 or a 0 because it only has two states, an on and an off. So unlike in counting, it can't represent any other numbers. Now, in the next section, I'm going to talk you through the binary sequence. In this box, the second box, I want you to take notes. Now, this is what we call our binary sequence. When we used our hands before, you will have seen 1, 2, 4, 8 and 16. Hopefully, you figured that the number doubles. But all of a sudden, we have added 3 more numbers. That's because we need to represent numbers in bytes, and there are 8 bits in a byte. So we need 128, 64 and 32. Notice how the number 1 is on the right hand side here. The numbers, as we said, double, and this is why. When we have a 0 and 1, we know that these are binary digits. If we only have one binary digit, we can only have 2 options, a 0 or a 1. As soon as we move to 2 digits, so the 1 and the 2, we can actually have 4 different options, or 4 combinations. Off, 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 on, off, or on. Remember, 0s are off and 1 is on. That means we could represent 4 different numbers. Remember, we start at 0, but we could only represent 0, 1, 2 and 3. When we increase that and we have 3 digits, as you can see, we can actually represent all the numbers from 0 to 7 because there are 8 different options. Remember, we start at 0, so even though it goes to 7, there are 8 options. And we can calculate this because of the following formula: 2 to the power of n. And we're going to explain this and have a look at this now. When we had our 3 binary digits, we had 8 options. This would mean 2 to the power of 3 is 8. There are 8 different options. Now, the 2 comes from the fact that there are 2 options. Base 2, a 0 or a 1. 2 at the bottom here because there are 2 options. If we have 3 binary digits at base 2, that means we can have 8. And you can do that on the calculator. 2 to the power of 3 is 8. So when we have 3 binary digits that we can use, we can have 8 combinations. Remember, the 2 is for base 2. So we've said that already. There's a 2 here because there's 2 options, a 0 and a 1, and it is base 2. That means our binary sequence comes from our bases. Remember, we always start at 0, and we've said when we have a 2 to the power of 0 is 1, there are actually 2 options here, a 0 and a 1. This is the only funny one just here. When we go up, and we've just seen when there are 3 digits, 2 to the power of 3, there are 8 options. When there are 2, so just a 0 and 1, we could make 4 options, and we can keep going up like this. To finally 2 to the power of 7, which is 128. Now that means what's the biggest number you can make in binary? And you can see it on the screen already, 255. That would be if all our ones are on. Don't get confused here. 2 to the power of 7 would give us 128. But we've got 8 options. So 2 to the power of 8 is actually 256. So we know the biggest number we can make in 8-bit binary is 255, because this value here is actually 2 to the power of 7. Because of the 1 at the end, it's not 2 to the power of 8. That would mean that we have to do 1 minus, and it would give us 255. There's our 255 value. We know that most computers can only have 8-bit binary. So if we did want 256, we would need 2 bytes, looking like this. Remember, think about it like this. We have lots of switches together, remember, to make our bytes. And in this instance here, to find out what binary number this is, we add up the ons, or the ones. So we count 128, we don't count 64 because that's off, add 32, add 16, and add 4, which gives us 181. So this value here would be 181. I want you to try this task in your workbooks now. Pause the video and see if you can complete it. You should have done task 1, here is task 2. Replace the binary with denary. So inside your work here, replace that binary value with a denary value. You can use the table to help. If you finish, complete the extension at the bottom of the page. Here are the answers. Have a look, check yours through, and make sure you are happy with those. Your next task is to try this binary sequence game. The link is in your workbook. This is what it will look like. What you've got to try and do is guess what the binary number is. So we've got 4 add 1 is 5. Click enter and it will remove it for us. 8 plus 2 is 10. Now the ones where you can type, you've got to figure out what the number is. But the ones which just have a number, you've got to actually put the binary in yourself. So 1 is just here, 4 plus 2 is 6, plus 1 is 7. Now we've all just done that, so we're going to do that quickly. 10 is 8 plus 2, and that would be our binary digit. That's 2, 1, 16 is an easy one, 9, 8 and 1, and you can see how it goes. We'll give you a score at the top, and you lose once the blocks fill up. A bit like the old game Tetris. Have a good practice with this game. It's a really good way of you practicing binary. Now we go back to our puzzle. There are 10 types of people in this world. Those who understand binary and those who don't. Can you solve the puzzle? It's actually not 10, it's 2. A 1 and a 0 would be 2. So there are 2 types of people in this world, those who understand binary and those who don't.